Hey, what's going on, everybody? It's me, it's your old pal, the original gamer, Stevie Stroh, and what I'm doing now is continuing this obsessive journey with going over how to program your color computer in BASIC, and we are now up to Chapter 8, and the name of this chapter is called Reading. Now, I came up with a pretty good idea on what I'm going to start doing on future chapters, so starting with this chapter, this is going to be a little bit of a catch-up, but I'm going to have a little slideshow that's going to kind of summarize what we have covered. So if we take a look at that real quick, we are starting off on a book that's called Getting Started with Color Basic, which is the most simplest version of the BASIC language, which is kind of redundant because BASIC is a simple language to begin with. But there's two versions of BASIC. So there is Color Basic, and then there's Extended Color Basic, and then technically there's a third for the Color Computer 3, which I think they call Super Extended Color Basic, but we aren't there yet. So we're going to be going over first the standard or traditional color basic language. We have covered something like 7 chapters so far. So let's kind of review what we have learned so far. Chapter 1 was called Meet Your Computer. And some of the words, the basic words that were introduced to us were the command called print, which allows you to display both text and numbers on the screen. It introduced us to the command called sound that lets you generate sound that you can hear. And then it introduced us to the word called CLS that allows you to clear the screen or clear the screen in one of 9 available colors. It introduced us to a couple keyboard characters. It introduced us to the backspace, which is basically the left arrow, and it introduced us to pressing enter on our keyboard. In the concepts, it first explained to us as well as the concept of a string versus a number and error messages. And so just to remind you, strings are wrapped in quotes. They have quotes wrapped around them, and they are strictly text. A string variable has a $sign at the end. A numeric variable is strictly a number. There is no quotes around it, and there is no $sign after that variable letter. So that is a little bit of what Chapter 1 introduced us to. Chapter 2 was called Your Computer Never Forgets. So string variables wrapped in quotes, ends in a $sign. Numeric variables has no quotes or $signs. Demonstrate computer math on variables. So if you say x equals this and y equals that, what is x plus y? What is x times y? What is y divided by 2? So doing math on a variable, which coincidentally is when algebra finally made sense to me. It was when I started programming because I actually had a frame of reference to apply it to. Variables can be 1 or 2 characters. So like, for example, a string is a variable. A is a variable. You could have up to 2 letters. So you could have AA, BB. You could have, like, SC for score. Your variable can be up to 2 characters. The first character needs to be a letter. If you're only using 1 character, then it has to be a letter. And just bear in mind, there's only 26 of those letters in our alphabet. But if you wanted more, you could do either 2 letters or a letter and a number. So you could have like A1, A2, A3, A4, etc. So those are just different ways to label your variables. You have a couple combinations of 1 or 2 letters, or a letter and a number, or just a letter. So chapter number 3 was it was called See How Easy It Is. The basic words that introduced us to were new, input. New clears memory. Input is a way to input either a string variable or a text variable. Go to is a way to get your computer to go back somewhere. Run is the command to run a program. Print, comma, prints things in columns. Print, semicolon, crams things together. List is how you kind of scroll your program on the screen. And it also gave us a sneak peek of the concept of if and then, which are better explained in a later chapter. The concept also was how to change or delete a program line. And the keyboard button that it introduces to is the break key, which on the real Coco is a red key in the top right-hand corner that allows you to break out of your program. Chapter 4 was called Count to the Beat. And interesting commands and concepts introduced here. The concept of the for next loop. So for x equals 1 to 100 is telling it to start at 1 and keep going to 100. Next would say do it again, do it again, do it again. If you put the word step in between there, you can say step 2 means count by 2, step 4 means count by 4. So the for next loop is a way to kind of process through something a certain number of times. The step is a way to get it to skip steps along the way. The other concept here was teaching your computer to count. And then the keyboard, key sequence that was introduced to us was pressing shift, holding down shift and pressing at. And shift at will pause your computer. If your screen is continuously scrolling stuff on the screen, shift at will pause that. So chapter 5 was called Watch the Clock, and it reminded us of the command called CLS, where you can clear the screen. The concept here was nested loops, which is basically a for next loop inside a loop or a loop within a loop. Also introduced us how to count time, real time. So as it turns out that our color computer, if we do a for next loop and we start counting on 1, it takes us to the count of 460 to equal 1 second of real time on Earth. And once again, shift at to pause the screen was one of the commands that was, or keyboard sequences that was demonstrated in this chapter. This brings us to chapter 6, which was called Decisions. The words here were if and then and end. So if then is a great way to have to make decisions within your software, to compare things. And so if this is true, then do that. If this is false, then do that. If I'm asking for red or blue, make your screen red or blue. If they didn't answer red or blue, then tell them, quit playing around and give me what I want to know, and go back and keep asking them until I get what I want. Lots of different things that's going on there. So I call that branching your code, going off in different directions based on the decisions you make by comparing either string values, which is text, or numeric values, which is just numbers. You can do an if-then decision and then do something based on the results of that decision. Chapter 7 was called Games of Chance, which I really enjoyed. And the two commands that it introduces us to are the RND command, which is abbreviation for randomize or random. And it also introduces us to a command called print at. So generating random numbers is a great way to play games or to make games. For example, rolling the dice, which is one of the examples they do. A card game, right? So when you play cards and you have to shuffle the deck and you throw those things out, those are random, right? So that was a cool concept, and I use that a lot in most of my early games that I made in the 80s and the 90s. And then also print at is like locating text on a particular part of the screen. So being able to precisely center something on the screen or print something in a specific location of a screen, also very important concepts. Which brings us to the chapter that we are going to cover today, which this chapter 8 is called Reading. And you're going to learn a bunch of new words. You're going to learn the word data or data. You say tomato, I say data. You're going to learn how to read this data. You're going to learn how to restore data. You're going to learn the INT command, which stands for integer. And you are going to learn the concept of clearing, which is clearing out space in memory to reserve for data to be read into memory. The concept here is reading data into a variable. Determining if a number is a whole number, meaning it's an even number, or an odd number. So for example, if you divide 2 by 2, that's not a bad example, that's 1, but 1 is still a whole number. But if you divide 4 by 2, the answer is 2, and that's an even number. That is a whole number. If you divide 3 by 2, you would get 1.5. And so anytime it ends in a decimal, that is an odd number. So that's a quick way to tell if a number is even or odd, and sometimes that is helpful. So there you have that. And now that we have that, now that we know what we're going to talk about, let's go ahead and jump into the book, the chapter, and let's see what this crazy book wants us to do today. So today it's introducing us to the concept of reading. It says your computer is is natural at teaching, it's patient, it's tireless, and it never makes a mistake, depending on the programmer, you of course. It also can be imaginative, consoling, and enthusiastic. Using the random command, RND, have it teach you math. Here is the program it wants us to type. So we're going to type in 10 CLS 20 x equals RND parentheses 15. That generates a number between 1 and 15. 30 y equals RND parentheses 15. 40 is going to say print quote what is end quote letter X quote star end quote letter Y outside of quotes, and then we wrap a question mark in the quotes here. Let me put some space. Oh, I can't. There's no editing here. Never mind. I was going to put a little bit more spaces in here. So what is this saying here? When I say print quote what is, that part will show up as text. The letter X here that is actually between two sets of quotes, that's a variable. So that is going to actually print out the numeric number that was generated randomly here. This asterisk, which is how the computer uses for its multiplication symbol, that is inside quotes, so that'll print literally as a string. The Y, although it's confusing, the Y is actually not surrounded by quotes, so that's another numeric variable as defined here, Y equals random 15, and then the question mark is actually in quotes. So let's just say it generated a 1 and a 2. What you'd see on the screen is, what is 1 times 2? All right, so that's kind of what's going to show up there. So let's go ahead and move on to our next line. Line 45 says input A for your answer. So it's basically saying what is this? It's allowing you to input your answer. And then line 50 is now doing if then, which we learned in the last chapter, to compare your answer if it's correct. So if A, meaning your answer, equals X times Y, meaning you answered what the proper multiplication is, then 90, which means jump down to line 90. And you can kind of see here in the book, they're showing you here that it would then jump down here to 90 that says print correct. But I digest and I'm getting ahead of myself. Now as we go over here to line 60, if you didn't get it right, it's going to say print quote the answer is end quote, and then we're doing X times Y, which is going to show you the multiplication proper answer. 70 says print quote better luck next time. 80 then goes to 100. 80 is to go to 100. Now we go to line 90, which was previously kind of hinted at over here in line 50. If A equals X times Y, then 90. Now that we're down here on 90, 90 is going to say print quote correct, 3 exclamation points. Line 100 is going to say print quote press enter when ready for another, end quote. Line 105 says input a string. Line 110 says go to 10. Here's our entire program, and let's run it through here real quick. So 10 is going to clear the screen. 20 is going to generate a random value for a variable called X between 1 and 15. 30 is going to generate a random value for Y between 1 and 15. 40 is going to say what is X times Y, put it on the screen, give you a chance to do it in your head. It's going to input a variable called A. You will type in the answer you believe to be true. It will then compare your answer towards the actual math to see if you're right using if and then. So if your answer equals the correct answer, then it's going to go to line 90 that says you got it right. Now obviously if it doesn't, then if it doesn't go to 90, it's going to continue going through the code in sequence. So then line 60 says, well, sorry there, knucklehead, but the answer actually was this. 70 will say print better luck next time. 80 says then go to 100 because we're skipping over 90 because we don't want it to say you got it correct when you didn't. And then 100 is basically a thing to branch back and loop over again. Press enter when ready for another. So let's give that a try. And of course now, because we're dealing with math, not my best subject, but what is 8 times 5? That one I can do in my head. It's 45. Oh, shoot. What an idiot. I knew that. I'm sorry. I was thinking of 9. Better luck next time. Well, anyways, I screwed up, right? So now I have to fix my spelling. So line 70 actually should say print better luck next with a T time. All right, let's run it again. All right, what is 3 times 10? That I know, 30. Correct. Press enter when ready for another. Okay, what is 7 times 5? 35. Woohoo! I am impressing the heck out of you people, right? So press enter. What is 9 times 5? That one's 45. So you can see here now, let's get one wrong on purpose. 2 times 13. I'm not trying to impress you, but I know it's 26. I'm just going to say it's 25. It says, no, the answer is 26. Better luck next time. Press enter when ready for another. So there's our program. Now, this program in itself, not that amazing, but I want to get in the habit of saving our program. So I'm going to go ahead and save this. Save quote. I'm going to just call this one, because it's chapter 8, I'm going to type in 8-47 for the file name, because this is the program as it stands in chapter 8 on page 47. And if I type in dir, it's there. So now as we modify this program, I'm going to save it with different revision file names so we can go back and look at the different versions of this program as we continue to flesh it out, because this chapter will have us do more to this program. So let's continue on here. Now, here it says, so I guess I need to finish reading this, right? So if the program drills you, okay, do it yourself. Let's zoom into the bottom of the page here. So the do it yourself challenge here is make the program drill you on addition problems from 1 to 100. So in this case here, X is going to be random 100, Y is going to be random 100, and instead of using the asterisk to multiply, we're going to use the plus sign to add. That is what it's asking us to do. So we'll go back. Let me scroll down to the next page. And so now here's it's basically saying, here's your change to the code. So it's saying the lines we've changed is now kind of what I said, X equals random 100, Y equals random 100, print what is X plus Y, and then the logic and everything else. So if we go back to our program, let's just hash it through. So line 20 should say X equals RND 100. Line 30 should say Y equals RND 100. Line 40 should say print quote what is, I'm going to space this out now, what is X, space this out, put it in quotes, plus, space that out, Y, space that out, put that in a question mark. So what you can see here now is I'm actually spacing out the difference between the string texts and the variables. So when I print quote what is, you're going to see that literal text on the screen. The X is not in quotes, so that is going to be the variable that was randomly generated here. Y is not in quotes, that's going to be that variable. The question mark is in quotes, so that will show up. So we've just finished fixing line 40. Now I need to relist my code as to see what else I have to fix here. So we fixed the question, now we have to fix the logic. So line 50 should say if your answer equals X plus Y, then 90. And then line 60 is going to say print quote the answer is end quote X plus Y. So if I relist that, we're going to see now that I've made everything. And I love it when a program fits on the screen and takes up less than my 16 lines of text. I wish all programs should be this easy to view and debug. So line 10, CLS, clear screen, X equals random 100, Y equals random 100. Ask the question, what is X plus Y? Input your answer. If your answer is correct, print that you got it correct. If it's not, tell you what the answer is. Go to 100, which says press any key to start over, or press enter to start over. So let's run it and see what we get. All right, what is 84 plus 12? That would be 96. Correct. Press enter when ready for another. What is 60 plus 62? That would be 122. Correct. Press enter when ready. What is 91 plus 98? That's 99 plus 90. That's 189, I think. Correct. All right. Boom. Had to break that down into Common Core math to make that work. Press enter. What is 96 plus 65? I have no frickin' idea. Let's just say it's 45. The answer is 161. Okay. So we have just modified our program again based on the top half of the page. And so I'm going to save this again. And so now what I'm going to save this as is I'm going to save this as Chapter 8, page 48-1, because this is the first program on 48. It's actually going to have us change it again. This is correct. Yes, 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 yes. So save it. If I type in dir, I now have 48 program 1, chapter 8, page 48, program 1. Luckily the pages are just going to be very rare. You're going to fit more than 1 or 2 things per page here. Let's look at what this question is asking me. Let me zoom in a little bit. What's our so now it's asking us to do something more. Make the program more interesting. Have it keep a running total of all the correct answers. So for line 15, it's going to say your tries. Every time you ask a question, every time you go through a question, it's going to count how many times you've tried these questions. Line 95, which is after you get it correct, it's going to say C equals C plus 1. So your correct counter is going to increment each time you get one correct. What you need to realize about a variable is that if a variable has never been previously defined, where right now t has not been given a value. So when I say t equals t plus 1, t starts off at 0 unless you said t equals 1 or t equals whatever. So since t has never been defined with a value, when I say t equals t plus 1, I'm basically saying t equals 0 plus 1, and now t equals 1. As we go through it again, it'll say t equals 1 plus 1, because it already was 1. We keep adding 1 to its value, and then it increments by that. But they always start off on 0, just so you know. So your tries will keep incrementing by 1, and your correct answers will increment by 1. So let's go ahead and type that in. So we will type in here on line 15. Oh, crap. What did I do? What did I do? That's what I did. I moved this out of the way. I don't know how I did that. I've got to fix that. Okay. So I was clicking in the wrong window for starters. So line, let me make this bigger again so I can read it, because I can't read it. All right. So we're going to add line 15, and we're going to say t for tries equals t plus 1. We are going to add a line 95 that says C equals C plus 1, which means our counting is going to increment. And then we're going to add a line 98 that's going to say print, quote, that is C correct out of, quote, T answers. All right. Now, T is the counter, and then let's go ahead and run it and see what happens here. So when we run this, what is 17 plus 64? Why do you have to give me the hard ones? That would be 7181. Yes, correct. That is 1 correct out of 1 answers. Press enter when you're ready for another. 52 plus 79, that would be, 81 plus 51, 31. Correct. That is 2 correct out of 2 answers. Press enter. What is 23 plus 59? Why are you giving me all this difficult math here? That would be 62, 82. Correct. That is 3 out of correct. And so what is 3 plus 72? That's 75, and so on. So what we're doing here is we're spicing up this program just a little bit by adding more stuff to it, which is kind of cool. Let's break out of it now. And I'm going to save this one more time. I'm still on page 48, so I'm going to save this as chapter 8 page 48 program 2. We'll save it again. We're actually getting ready to start a new program, and we're going to be starting all over. So one of the things that didn't ask us to do is to type in new to clear things out. But hold on, one more thing here on the screen. Let's zoom in. I have such a hard time reading this. Do it yourself. Make the program more fun. Have it do one of the following. Call you by name. Reward your correct answer with sound and a light show. Print the problem and message attractively on the screen using the print at command. Keep a running total of percentages and end the program if you get 10 answers in a row correctly. Use your imagination. So those are some cool options. Those are some great suggestions, but those are things I am not going to do right now because this is a long chapter. This is going to be a long video. So build your computer's vocabulary so it can build yours. Type and run this program. So we're now on the bottom of page 48. So I'm going to go back here. I'm going to go ahead and type in new, clear my memory. And then the program it wants me to type in is this. It wants me to type in some data. So line 10 is the word data, new vocabulary word that we're getting introduced right now. Apples, comma, oranges, O-R-A-N-G-E-S, comma, pears. So here's 3 pieces of data we have just put in our program. And so this is interesting how this works right now. We are putting stuff in our program, and it's in our program, but it's kind of not in use yet. The only time it's going to get called into use is if we read this in. So data is kind of like putting words on a page, and the read is then reading those words off the page and putting them into memory and sticking them into a variable. Now, as it turns out here, we have actually put 3 words into a data statement here. So line 20 is basically going to have your computer count to 3. So it's going to say for x equals 1, 2, 3. Line 30 is going to say read f string. And so what's going to happen here is that it's going to read the word apples into a string known as f. Then as it goes along to the next one, it's going to read the word oranges. And then lastly, it's going to read the word pears. That's exactly what's going to happen. And so then line 40 is going to say next X. So it says to build your vocabulary, type it in and run this program. Now when I run the program and I hit run, it just says okay. So now the book says what happened? Nothing. Nothing you can see, that is. To see what the computer is doing, add this line and run the program. So now it wants us to add in line 35 to print out what f string is as it gets read in. So we're going to say print quote f strings equals space semicolon end quote, and then we're going to actually type in the literal f string, which is the variable that's getting read here. So line 30 is going to read in one of these words into a variable known as f string. Line 35 is going to say, well, f string is the equivalent of, this is all printed in text, and then it's going to print out the actual f string variable that got read right here. So when we do all of that and we run it, not fur, it's run. When we type in run, these were the 3 words that got read. It read in apples, it read in oranges, it read in pears, and it allowed us to display those as we were doing them. So it says line 30 tells your computer to look at the data, etc. So we're flipping pages now. We need to go down to the next page, and then it's kind of explaining to us even further. It says give apples the f string label. It's kind of crossing out apples. From memory, the second time your computer goes to line 30, it's told to do the same thing. It looks for a data line. It reads the line in. This time it's oranges. It gives oranges the f string label, and it crosses oranges off from its memory. It will continue to do this until it reaches pears. It says, what if you want the computer to read the same list again? It's basically saying that the first time you read through things, it's crossed everything off. So now it's saying for line 60, type in 60, go to 10. So if I list out my program, and right now my program has got 3 pieces of data. It's telling it to read this data 3 times. As it's reading it, it's printing on the screen, and then it finishes. So now it says for line 60, type in 60, go to 10. What is going to happen? The first time I run it, it printed it out 3 times, and then it gave me an OD error, which stands for out of data. So what it's telling us here that is when you want the computer to read the same list again, it's already crossed out, but you run the program, you're going to get an OD error. OD means out of data. Your computer crossed out all the data, so it says now type in this line to run the program. We need to, before we go back to 10, we need to type in a line that's called restore. So line 50 will be the command that's called restore. So I'm going to type in 50 space restore. If I list this out, you're going to see that line 10 has 3 pieces of data. Line 20 tells it to count 3 times, read data, print data, finish counting. Line 50 then says restore, which means go back to the top of the page, go back to the beginning of the data. And then line 60 says go to 10 and start all over again. So when I run this, what we should see is a continuous loop of these things printing over and over and over again. You could press Shift At to pause this, or you could press Break to break out of it, and the break key on your emulator is the End key, E-N-D key, on your keyboard. So far so good. What we're learning here now is that we have to do things. And so now it's basically saying the computer never crossed out any data. It reads the same list over and over and over again for each of these programs. They all work the same. So now it's basically saying if I change the word, if I change the arrangement of data and I did them separately, I could say 10 data apples, 20 data oranges, 70 data pears. I can move the word data around to different parts of my program. It doesn't matter if the data is at the beginning of the program, the middle, or the end. The computer will look for the word data anywhere and continue to read data. And then do something with it. So on the bottom of page 49, it's basically just showing us that you can mix up the word data in a lot of different places within your program, but the read command will find it regardless of what line number is associated with it. So I'm gonna save us the misery of typing that in all those different times. But what I will do right now is I will save this. And so I'm gonna save this as chapter 8-49. That's where we are in the book. So when I type in dir, here's my program 8-49. Okay, so we are moving on because there's a lot to cover here. Now it's going to introduce us to building a vocabulary. I'm going to bring this in a little bit bigger so you can read it a little nicer. And so now it's basically saying here are some words and definitions to learn. The word is taciturn. Definition is habitually untalkative. The word is loquacious. Definition is very talkative. Word is vociferous, which is loud and vehement. The word is terse, which is concise. And the word is effusive, which is demonstrative or gushy. Okay, so vocabulary lessons there for you folks. So now, get the computer to select one of these words at random. So we're going to type in this code right now. Let's go back to my big screen. Let's make the Coco a little bit bigger, although I think I might need to get the book a little tiny bit bigger here too, and I'm probably going to type some of these things wrong here. So what I need to do now is I need to type in new, clear my memory, and here's my data. 10 is data, T-A-C-I-T-U-R-N, taciturn, comma, habitually untalkative. That's my first one. Line 20 is data, loquacious, L-O-Q-U-A-T-I-O-U-S, comma, very talkative. Line 30 is data, space, vociferous, V-O-C-I-F-E-R-O-U-S, comma, loud and vehement, V-E-H-E-M-E-N-T. Line 40 is data, terse, T-E-R-S-E, comma, concise. Line 50 is data, effusive, comma, demonstrative or gushy, booyakasha. So we have just loaded in all of this data on our screen here, and it's in 2 columns, right? So the first column is the word, the second column is the definition. I know it's in 2 columns because there's only 2 pieces of information here, all separated by commas. So what's next? So 60. Line 60 says n equals, well, I type in the word 60. 60 says n equals RND parentheses 10. So we're going to pick a random number between 1 and 10. I've actually got 5 lines with 2 words in each, so there's a total of 10 words in our data. You can think of this as a database of information, but instead of this database being on a disk somewhere, the database is actually somewhere within our program waiting to be read in. That's the best way to explain what data is. It's basically a database you are building yourself inside your software that's stored within your program. It's not stored on a disk. I probably should have said that before. It just came to me. Sorry about that. So now we're going to say n equals random 10. What is next? So 70 for x equals 1 to n, meaning we're going to start at 1 and go to whatever number it picked. 80 says read a string. So we're going to read so many times. 90 says next x. Line 100 says print, quote, the random word is, quote, and then a string. Now it says run the program a few times. What should ultimately happen is that, I'm not sure if we're going to get out of date. I wonder if each time I run it, if it will just clear memory. So let's try it one time. When I run it, the random word is vociferous. And I spelled random wrong. Let's do that one again. Line 100, print, quote, the random word is, quote, a string. Run it again. The random word is very talkative. Now you notice sometimes it's the word, sometimes it's the definition. If I run it again, the random word is habitually untalkative. So again, we're getting sometimes words, sometimes definitions. So what the book here is saying is run the program a few times. It doesn't quite work. It doesn't work quite right. The computer is just likely to stop it as a definition as a word. It says we want the computer, what the computer really needs to do is pick a random word only from items 1, 3, 5, 7, or 9. Meaning it wants you to pick an odd word, which is the ones in the left column, right? So it's the words and not the definitions. And it says BASIC has a word that helps us with this. Type in 65, new line number, if int or integer n divided by 2 equals n divided by 2, then n equals n minus 1. What does all of that mean? So we're going to pick a random number. Let's say the number we picked was 5. So what's 5 divided by 2? 5 divided by 2 is 2.5. What does int do? Integer makes this number a whole number. So it's just going to chop off any decimal point at the end. So the integer of 5 divided by 2 would not be 2.5. It would just be 2. It chops off everything after the whole number. So basically what it's saying here is if 2 equals 2.5, I'm confusing myself right now, then n equals n minus 1. So what it's saying here is if you divide by 2 and you're an even number and you exactly match the same thing, then we're going to subtract 1 and make you an odd number. It took me a minute to follow that logic, right? So if the integer, so if we were 4, if I picked 4, so 4 divided by 2 integer wise is still 2, and so if that equals the same thing, then we have determined you are an even number. We don't want an even number. We're going to subtract 1. We're going to make you an odd number. Hopefully that makes sense, right? The opposite side of this would be this. Going back to my first example. If you pick 5 and the integer of 5 divided by 2 is actually 2. And in that case here, that would not, the integer value would not equal the actual value. So the integer value would be 2.0. The actual value would be 2.5. So they don't equal, and at this point it wouldn't subtract them because they don't equal. They're not the same. So only if they're the same will we subtract 1 to make it odd. If they're not the same, we'll leave it where it is. So it took me a long time to spit that out, but basically this is the computer's way to determine if I am an even number. I want to become odd by subtracting 1 from myself. So let's try this one more time. Let's run it. And so now the random word is terse. And each time I run this, vociferous. Each time, taciturn. Each time I run it now, effusive. Each time I run it, I will only get the word in loquacious and not the definition. So that's kind of cool, right? So that's what the integer command does. It allows you to determine if a number is even or odd, and make some comparisons that way. Because when you divide an odd number in half, you're always going to get a 0.5. If you divide an even number in half, it's always going to be a whole number. So now, what's the next thing? It says, assume n is the random number, and now it's explaining it to you better. So if, let's say the number is 10. And in this case, 65 does this. 10 divided by 2 is the same thing as 10 divided by 2. And the integer of 5 is 5. 5 equals 5, right? So 10 divided by 2 is 5. Integer is 5. So 5 and 5 are the same. If it's not equal, so if 5 does equal 5, since the computer completes the then clause, it just adjusts it to that minus 1. So that's kind of explaining the whole process there. I know it's a little confusing, but hopefully you got that. We are going to move on, though, because there's a lot to cover here. But just kind of summarize that. The integer command is a way to determine if, or better yet, it's, let's say you don't want decimal points in a number. You only want whole numbers. That's another way to clean that up. But it's also a way to say, okay, the regular math is going to give me this, but if my integer math is different than that, that's my way to know this number is even or odd. All right, so now, okay, besides reading a random word, the computer must also read the word's definitions, and these lines, it says add these lines to the end of the program. So now we're going to add line 110. That's going to say read R-E-A-D B string. And then line 20 is going to say print, quote, the definition is, colon, quote, B string. Okay. It says now run the program a few times. So when I run it now, I can say the random word is loquacious. The definition is very talkative. If I run it again, the random word is vociferous. The definition is loud and vehement. If I run it again, the random word is terse. The definition is concise. So by now using two read commands, two read statements, and reading them into two separate variables, I'm able to pick both columns of information and be able to kind of distinguish the word from the definition from this data that we're doing in here. So it says have the computer print one random word and definition after the next. It says add this to the start of the program. Clear 100. So if I go to if I add line 5 and I say clear 100, that's clearing off some space of memory. It says this reserves plenty of string space and add these lines to the end of the program. So if I go to line 130 and I type in restore, and then I add line 40 and I say go to 60. If I list this out now, my program's pretty big, but line 40 is going to go back to 60, which is going to pick a new random number, and this is going to keep happening over and over again, and so on and so forth. So what we will end up seeing here is that these vocabulary words will run forever, and we'll never get an out of data message because we keep restoring our data and starting over. Whoops, unlist. What did I do wrong in 140? 140 is supposed to go to 60. Unlisted here. 140 go. I put in go to, but I forgot to do 60. Let's try it again. Here we go. It is scrolling, right? So this little program here is picking random words from our database that we created in our program. It's picking random words, picking a random definition, assigning them to two variables. A string is the word, B string is the definition. It's printing them on the screen, and it's going around and around and around. And again, it's making sure that it's cleared memory to reserve memory for this string space, and also make sure that it restores the database. So we go back to the top of our list of data. So every time we go to pick a new random one, we don't reach the end of our data, and then it's just repeating this infinitely. And so pretty cool little program. And so, what we see here is, we kind of see that we have put in 10 words. So we've put in, a word and a definition, word and definition, word and definition, word and definition, word and definition. We're picking a number between 1 and 10. If it's an even number, meaning it's a definition, we'll subtract 1 and pick up this word here as our A string, and then we'll pick up the second word as our B string. If it's not even and it's already odd, we know to pick that as A and this is B. So we pick the word in a string, definition in a string, we throw it up on the screen to let you know what it is, and we do this forever. That's what this program is doing. And again, the best way I can explain what data does is it's a way for you to put data that would usually live in a database, which is a file stored somewhere on either disk or cassette or a hard drive. It's a way to take information that would ordinarily be stored in a file, and you're storing it in your program, and it's not directly assigned into a variable until you read it into a variable. So it's a way to have stuff that you can pull on later and use in a variety of ways. So let's go ahead and save this program. We're going to save this as chapter 8-51 because that's kind of where we are. If we type in dir, we now have a variety of programs on here. What's the last thing it says on the bottom of this page here? Because I need to zoom in. It says when you want to complete this program, program it so that the computer prints the definitions only, asks you for the word, compares your word to the correct random word, tells you if your answer is correct. If your answer is incorrect, prints the correct word. That's actually a pretty cool little project. And so I'll kind of think that one out loud real quick. I'm not going to bother coding it just yet. But how would that logic go, right? So here's what would happen when you read in your word and your definition, all right? So you have your A string and your B string. So in this case here, those would already be kind of determined in the first part of the program. Then we would print a word on the screen. It would say the definition is B string. And then it's going to say what is the word? Input W string for words. Then it would compare that. If the word you type was the same as the A string that it read, then it would print the word correct. Yes, you got this correct. If it didn't, it would say, sorry, you are incorrect. The correct word was this. And then you can have it go around forever. You could also have the thing where you can also keep score. How many times have you been asked this question? How many times have you got it right? There's lots of other things you could infuse into there to flesh that out and make it more make it look more like a real game, make it seem more interactive. We will eventually get there, but I'm not going to beat us to death with that right now. But once again, if anybody's watching this and anybody wants to take that challenge and let that gauntlet be thrown, then by all means, write the program and then send it back to me, and I'll show it for you. I'll give you full credit for it, but I'm just not feeling like doing that right now because I'm lazy. What can I tell you? So what's the next thing we need to look at in this chapter? Because this is a pretty long chapter. We've got the final answer here. Actually, so never mind. It already gave us the information here. So let's go ahead and do it then. What the heck? Let's not be lazy. Let's zoom in on this right now, and let's add in a little bit more information here. If I was to look at my program, if I was to list out, let's say 1 through 60, the number it's cleared right now in line 5 is 100. It wants us to clear more. So I'm going to change 5 to say clear 500. Okay, that line has been fixed. The data is already there. 60 is randomizing it. 65 is this. Let's look at 60 through 90 right now and see where my code. So I'll do list 60 through 90. Where does my code work? Let's make sure those things match. Let's go back to Cocoa Big. Let's see. So my line 60 says n equals random 10. That's the same. 65 checks to see if it's even or odd. Okay. Now the numbering is a little bit different. So 60 says n equals random 10. 65 checks for the integer. 70 now says for x equals 1 to n. 80 is read 9 string. Okay, okay, that's good. So now let's read a little bit more here. That's still the same. So let's read 110 through 140. This 110 through 140. And let's see what exists right now. So right now 110 says read B string. Okay, 120 is going to change. So 120 is going to print quote the word means colon B string, kind of the same thing. Line 130 says restore, that hasn't changed, but line 140 now says input R string for your response. And now line 50 says if R string, if your response is the equal to the A string, which is the word, then 150. Line 160, if you didn't get it right, is going to say print quote wrong. Line 170 is going to print the correct word is colon quote A string. Line 180, oops, I screwed that up. 170 says print quote the correct word is colon a string. Let's get the string in there. Line 180 is going to go back to 60. Line 190 is going to print, quote, correct, meaning you got it correct. And then line 200 is going to go to 60. So it did it for us. Let's try it. It's going to pick a random word. What did I screw up? The word means concise. Well, I've got my cheat here. C-O-N-C-I-S-E. You are correct. Oh, it says wrong. The correct word is terse. The random word is terse. The word means concise. Oh, I have to get rid of the random word. I have to get rid of that line. The word means concise, so the word is terse. Screw that one up. So where do we have to fix that now? What line is, let's list 5, so let's list 110 through 150. Let's see where that goes. So 110 says read B strings. 120 says print the word means. 150. Where am I missing this at now? Somewhere it's giving me the answer still. The random word is line 100. There is no line 100. That's the problem there. So I need to get rid of 100. In order to get rid of line 100, you just type in 100, enter. That line is gone. So now when I type it in, 100 is gone. That's where I was getting confused. The word means habitually untalkative. Crap. I don't remember what that word was. That was your mom. No, wrong. The correct word was taciturn. The word means concise. That is terse. What are we waiting on here? Terse. T-E-R-S-E. I got a bug in my program again, do I? Where am I doing something right now? So, oh, 150. It's going to itself. If R string equals A string, and that's not then 150, it should be going to, if R strings equals A strings, then 190. So what I did is I had line 50 going back to itself. This is the fun of software. Word means habitually untalkative. Again, I forgot what that was, so that's going to be your mom. No, wrong. The correct word was taciturn. But now it gives me the same word again, so now I can cheat. Taciturn. Correct. This word means demonstrative or gushy. I forgot. The correct word was effusive. The word means habitually untalkative. I forgot. It is taciturn. I forgot. I don't know. Effusive. The word means talkative. That's loquacious. L-O-Q-U-A-T-I-O-U-S. Correct. So there you have it. This is kind of cool where it's reading in data and it's playing a game with it. This is basically like a guessing game. I'm thinking of a definition. You tell me what the word is. So kind of cool, kind of cool. And I think I need to save this one again. So I'm going to save this as save quote 8-52. So now what I've done is I have several revisions, or several different versions of a number of programs that we did in Chapter 8. And I'm saving them all out there. The thing about this is you only get 8 characters to save your file name. So you don't have a lot of room. So you can't say, well, this is the program about, you know, the Russian roulette, and this is a program about asking the questions. You get 8 actual characters. So I just did some real short stuff on here. So cool. Chapter 8 was cool. Let's summarize what we learned in Chapter 8 again. Chapter 8 was all about data. Data is a way to have information in your program. You start with the word data, and then you separate by commas, and you can either put in text or numbers. You can read in string value. You can read in numeric value too. You could have just a bunch of numbers separated by commas and read in a bunch of different numbers. Read is the command to read what's in data, and it automatically just picks the next thing in data. You can think of these as being in little blocks of memory, and it's just pulling them out from there. Restore is a way to say, go back to the top of the list, because it's keeping track of where it is as it's going through these little blocks of information. Restore says start from the beginning. INT, or integer, is a way to take a number and round it off to a whole number. There's a variety of uses and benefits to doing that. And then clear is a way to reserve an amount of memory that we can pull these strings into, because you will possibly get some out of memory errors by trying to pull stuff in that hasn't been cleared out. So a little bit technical here. I mean, all of it's technically technical. We're programming in BASIC, we're programming computer, but this is one that you really have to sink your teeth into and kind of wrap your brain around it. And I know this was long, and honestly, these last couple videos, I just been rolling the camera and I'm not editing anything. So when I make a mistake or I do something stupid, it's just there. Just bear with it. I'm sorry, but I'm trying to get this thing done. I want to get through this book. I want to get this information out there for myself and for anybody else who's interested in, so we can move on and get into the fun part of making a game. So editing the video is a luxury I can't afford right now, so deal with my human error. But other than that, thanks for watching. Really, seriously, thank you for watching, because you're crazy. But I appreciate it. So I've been the original gamer, Stevie Stroh. I hope you enjoyed this video. If you did, give it a like. Give it a big fat thumbs up. If you have something you'd like to say, throw out a comment and let me hear it. If you enjoyed this video, share it with your friends. If you didn't enjoy this video, share it with someone you hate. If you're new to the channel, click on that subscribe button and subscribe. I look forward to more programming in BASIC. I will talk to you all later. See ya. Keep on gaming. Keep on coding. Keep on programming. Keep on playing with your computers. Keep on playing with your color computer. Cocoa forever. Long live the cocoa. All that good stuff. Peace out, everybody.